All right, we are shifting to section 5.4 today. It is on polynomial division. We have two objectives. The first one is that we will be able to divide polynomials using a long division process. The second objective is that we will be able to divide them using synthetic division. Today our focus will just be on long division. Okay? Tomorrow we will talk about the synthetic process. It's a really cool shortcut. We use it for a lot of different things. However, not all polynomials can be divided synthetically. So you do have to know both processes. Okay? It says you can divide polynomials using steps that are similar to the long division steps you use to divide whole numbers. So we're kind of taking a trip back to 4th grade, okay, when you learn to divide. It says when you try to factor a polynomial, you are trying to find a divisor of the polynomial that gives a quotient, the other factor, and a remainder of 0. This suggests that being able to divide one polynomial by another could help you factor them. I'm going to give you an example. You don't have to write this down, but if I said to take 8 divided by 4, okay, and again, in our long division process, we would write it like this, okay? 4 goes into 8 how many times? 2. Our process was to put the 2 on top, multiply the 2 and the 4 together, and write that underneath, and then we subtracted. Yes? And we ended up with no remainder. And we got no remainder because 4 goes into 8 evenly. Yes? So 4 is a factor of 8. 2 is also a factor of 8. If you take the 2 and the 4, multiply them back together, you get back to your 8. Okay? Well, we're going to do that same process, but instead of just whole numbers, we're going to have polynomials. All right? It says numerical long division and polynomial long division are similar. We are going to start out with just a regular whole number division problem because I'm not as concerned can you do the number part of it as do you remember the steps, the process we use. Okay? So we are taking 672 and we are dividing it by 21. Now I want you to think back to when you were in 4th grade. Okay? 672 is a big number for a 4th grader. So you rounded. You just looked at the first number and you said, I've got a 6 here, I'm trying to divide it by a 2. How many times would a 2 go into a 6? It would go in 3 times. So you wrote a 3 on top and then you multiplied the 3 with the 21. Yes? 3 times 21 is 63. You wrote that underneath and then you did what? You subtracted it. So 67 minus 63 gives you a 4. And then what was the next step? Bring down the 2. And you basically just kept repeating that process. Now we have a 42. We're going to think 4. We're dividing it by 21. We're going to think 2. First term divided by first term. 4 divided by 2 is 2. We're going to put a 2 up at the top. 2 times 21 is 42. And when we subtracted, we had no remainder. Okay? That tells me that 21 is a factor of 672. And the other factor that goes with it is 32. So 21 times 32 would get us 672. Does that make sense? Okay. I want you to compare that question to our next one. Do you see similar numbers? In the first one, we had a 672. In this one, we have a 6x squared, a 7x, and a 2, 672. We were dividing by a 21. Now we're dividing by a 2x plus 1, 21. So the only thing different when we have polynomial long division is instead of having numbers where we think of, these are ones, these are tens, these are hundreds, we're going to have, these are my constants, these are my x's, these are my x squareds. Right? Each column is going to have a different kind of term in it. but the process is the same. So we're going to take 6x squared plus 7x plus 2. We're going to divide by 2x plus 1. Bless you. We focus just on the first term. Don't worry about how long the polynomial is. Take the first term and divide it by the first term. Okay? Kind of like we rounded on the last one. If I take 6x squared and I divide out a 2x, what is left over? A 3x. That 3x is going to go up on the top as part of my quotient. Just like in the last problem, we wrote a 3 on the top. Now we're going to take the 3x and this whole thing, the 2x plus 1, and we're going to multiply them back together. Just like on the last question, we took the 3 times the 21. Now we have a 3x and a 2x plus 1. We're going to multiply them back together. We get 6x squared plus 3x. That goes underneath here. Kind of like the 63 that we had on the last question. Now, the next step is where 99% of the problems happen. If you get the long division problem wrong, it's probably because you subtracted wrong. So please take time as you're going through these and subtract carefully. If you find that you're making mistakes a lot, I would take this negative sign and distribute it in. So then you can focus on just adding your columns. Okay? We are taking 6x squared. We are subtracting a 6x squared. There's nothing left for my first column. That should always happen. When you do the subtraction process, that first column should always disappear. If it doesn't, you did something wrong, go back and fix it. Don't keep going. All right, first column is gone. I go to my next column. I have a 7x. I'm subtracting a 3x. That leaves me a 4x. And then I'm going to bring down my next term, positive 2. And I'm going to repeat the process. I'm going to take the first term divided by the first term. So what do we get if we take 4x and divide it by 2x? We get a 2. That number, remember, goes up on top. Then we take 2 times the whole thing. What do we get if we take 2 times 2x plus 1? All right, and that goes under here, and we subtract. 4x minus 4x is gone. 2 minus 2 is 0. We have no remainder. So that tells me that 6x squared plus 7x plus 2 factors into 2x plus 1 and 3x plus 2. Another way of saying that, 6x squared plus 7x plus 2, when we divided by a 2x plus 1, gave us a 3x plus 2 without any remainder. Okay? All right. In the box here is kind of the formal way of saying all of that. I'm not going to ask you to rewrite this on any test, but I do want you to understand what it's saying. It says you can divide a polynomial p of x by a polynomial d of x to get polynomial quotient q of x and remainder r of x. We are taking some polynomial. We are dividing by another polynomial. All right, that's our divisor. We get a quotient for the answer, and we get some kind of remainder sometimes. Sometimes it's 0. Okay? If the remainder is 0, then p of x is the same as d of x times q of x. Okay? If we get a remainder of 0, then these are the two factors that create the polynomial. To use long division, the original polynomial and what you are dividing by, p of x and d of x, should be in standard form with 0 coefficients where appropriate. I want you to underline that. It needs to be in standard form with 0 coefficients where appropriate. What that means, you're going to use a 0 as the coefficient of a term if you are missing the term. I'll give you an example back to whole numbers like you did in 4th grade. If you were told to take 1072 and divide it by 205, you had to have the zeros in there, right? It's not the same. I can't just simplify this and say, I don't want to make it that hard. I'm just going to do 25 divided by 172. I'm not going to get the same answer because those numbers were a certain place value. You had ones, tens, hundreds, thousands. You can't change that 1,000 and make it a 100. Okay? So you had a 0 in there to hold the spot, to make sure everything was lined up and your place values worked. Well, same thing happens with polynomials. If you are missing any terms, you want to think of there being 0 of those. Put a 0 in there to hold the spot. So if I said to take x cubed plus 5x squared plus 7 and divide it by something, which term is missing? My x's. It's in standard form. I have my cubes, I have my squares for second power, but I don't have my x to the first power. My constant is like saying x to the 0, so that's fine, it's in the right order. But I'm missing those x's. So when I write it out, I would say x cubed plus 5x squared plus 0 x's plus the 7. Does that make sense? By putting those zeros in, it's going to make your columns line up correctly so you're subtracting right. When we do synthetic division tomorrow, it's critical. You have to have zeros in there for missing terms. Okay? So whether it's in the polynomial position here or in the divisor position, any missing terms, put a 0 in to hold that spot. All right. So we are going to take 4x squared plus 23x minus 16, and we are going to divide it by x plus 5. Am I missing any terms in this one? No? Okay. Remember, our process is to take the first term divided by the first term. So what do we get if we take 4x squared and just divide out an x? Okay. The 4x is going to go up on top. Then we take the 4x and we multiply it to the x plus 5. What do we end up with? Okay. And then the next step is to subtract. When I subtract, the x squared terms disappear. What do we get for x's? Okay. So 23 minus 20 would be 3x's. And then I bring down the minus 16. Repeat the process. Take your first term, the 3x. Divide out the x. We get 3. That positive 3 is going to go up on the top. We're going to take 3 times x plus 5. And we end up with 3x plus 15. And then we are going to subtract. What do we get when we subtract? Okay. The x's disappear. We have negative 16. We're subtracting 15 more. We are in the whole 31. Okay? So, how I could write this out. If I were told to take 4x squared plus 23x minus 16 and divide it by x plus 5, I can say my answer is 4x plus 3 plus, I have a remainder. Yes? Now when we did whole numbers, when you first learned division, you probably just wrote like r negative 31, right? You just said here's my remainder. Then you started learning about fractions, and you said, okay, well, that 31, that negative 31, is trying to be divided by x plus 5. It's just too small. I don't have any x's to pull out. So I would put down here that I have a negative 31. It's being divided by x plus 5. I just can't simplify that anymore. That would be the fraction part that's left. Okay? Now, we can check that. Remember the question we did earlier? We did 8 divided by 4, right? If I do 9 divided by 4, I have a remainder of 1, yes? So we would write that as 9 divided by 4 is 2 plus 1/4. Okay? We can also say that 9 can be found by taking 4 times 2 and adding in the remainder. So I could do this on this question as well. I could take x plus 5 times 4x plus 3. I could FOIL that together. I could add in the extra negative 31 that I have left over, and I should get back to this. Okay? Now, I'm not saying you have to check every single question. If this were a test question, I would go through, all right, with my extra time at the end of the hour, I would go through and double check that I didn't make a mistake with all my subtracting. Okay? So, you take the divisor and the quotient, multiply them together, add in your remainder. So divisor times quotient, add in your remainder. And you should get back to your regular polynomial. Okay? All right, let's try one more. I'm going to set this one up, and then I'm going to pause the recording so you guys can try it. You are dividing by x minus 7, and you are dividing it into 3x squared minus 29x plus 56. Again, no missing terms, so I don't have to worry about any zeros right now. All right, go ahead and try this one. When you are finished, check in with the people at your table. All right, checking our work. We have 3x squared. We are dividing out an x, so we end up with a 3x left. 3x times x is 3x squared, and 3x times negative 7 is negative 21x. We are subtracting that whole thing. Now, if you put the minus out here, you better have parentheses around that row. You're subtracting that whole polynomial. If you want to distribute it in, that's fine, but you can't write this, because then it looks like you're just subtracting the 3x squared. Does that make sense? You're subtracting the whole thing. All right. If we go ahead and distribute it in, makes that negative, makes this one positive. Now I'm adding my columns. My x squareds disappear. What do I get for my x's? Negative 29 plus 21. Okay. Bring down the 56 and repeat the process. So negative 8x divided by an x is negative 8. Multiplying, we get negative 8x plus 56. When we subtract all of that, what happens? Okay, so we had a remainder of 0. That means that 3x squared minus 29x plus 5, or plus 56, divided by x minus 7 gave us exactly 3x minus 8. It also means that 3x minus 8 times x minus 7 should get us back to 3x squared minus 29x plus 56. So we can use this to kind of factor our expressions. Okay. All right, our last two questions deal with checking to see if something is a factor. So we just said because we got a remainder of 0 on that last question, that x minus 7 was a factor of the polynomial. So the question here is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5? If it is, we should get a remainder of 0. If we don't get a remainder of 0, it's not a factor of it. Notice in here that we are missing some terms. I have an x squared plus 1. I'm going to have to write that as x squared plus 0x plus 1. There are no x's. By putting that in there, it's going to make all of my columns line up appropriately. So in the margin next to this question, make a little note. Watch for missing terms. Am I missing any in the regular polynomial? Which one? The x's again? So I have 3x to the 4th minus 4x cubed plus 12x squared plus 0 x's plus a constant of 5. Okay. Going through our process. We have x squared being divided out of a 3x to the 4th. What do I have left if I divide out an x squared? Okay. 3x squared now is going to get multiplied to all three of these pieces, okay, to this whole trinomial. So 3x squared times x squared is 3x to the 4th. 3x squared times 0x. I want you to think about that for a minute. 3x squared times 0x. 3 times 0 is 0. X squared times x. So I am going to end up with 0x cubes. Okay, notice that lined up with my other x cubes. And then multiplying it to the 1, I just have 3x squared. I need to subtract that whole polynomial. My first column disappears. 3x to the 4th minus 3x to the 4th would be 0. My second column, I have a negative 4x cubed. I'm subtracting nothing, so I still have a negative 4x cubed. In my third column, I have a 12x squared, and I am subtracting 3x squareds. That leaves me with 9x squareds. I'm going to bring down my next term, which in this case is a 0x. And I'm going to repeat the process. Take your negative 4x cubed. Divide out your x squared. What do we have left over? Okay. The negative 4x goes up on top as part of my quotient. I multiply it to that whole trinomial, which gets me negative 4x cubed. It gets me 0x squareds, and it ends up being a negative 4x for that column. When I subtract that whole row, the x cubes go away. I have negative 4 of them. I'm subtracting negative 4 of them, so I have nothing left. I have 9x squareds. I'm subtracting nothing. And I have 0, and I'm subtracting a negative 4x. What happens when you subtract a negative? You're really adding. So 0 plus 4x would be 4x. And then we bring down our final term, and we go through it one more time. 9x squared, if I divide out the x squared. Okay? It's a positive 9. Make sure you include the signs. 9 times x squared plus 0x plus 1 gets me 9x squared plus 0x plus 9. What do we get when we subtract that? First column's gone. 4x minus nothing. 5 minus 9. How do I know that that is my remainder, that I can't keep going? It's smaller, okay? I am trying to divide out x squareds, right? Every time I was dividing out an x squared, I don't have an x squared to take out. So as soon as the power here is smaller than the power you're trying to divide by, you're done. That's your remainder. So because my remainder is not 0, I would say x squared plus 1 is not a factor of that. Okay? if I had to write out the whole answer, my answer was, my quotient, 3x squared minus 4x plus 9 plus the remainder piece. And remember, we write it as a fraction. So I have this 4x minus 4. I'm trying to divide it by x squared plus 1. It's just too small. So that would be the fraction part that's left over. Okay? All right. Last one. We are checking to see if x minus 2 is a factor of x to the 5th minus 32. What do you notice about this one? A lot of missing terms. All right. Let's write it out. We have an x minus 2. We're dividing it into x to the 5th plus 0x to the 4ths plus 0x cubes plus 0x squareds plus 0x's minus 32. Okay? What happens to any power when I divide by an x? So if I have x to any power and I divide out an x, what happens to the power? In other words, if I have x to the 7th, I divide out an x, I get x to the 6th. If I have x to the 5th, I divide out an x, I get x to the 4th, right? My power just goes down 1? Okay, and all we're doing is dividing by x's. So this will be a little easier. X to the 5th divided by an x gives us x to the 4th. X to the 4th times x, and x to the 4th times the negative 2. And then I'm going to subtract. My first column disappears like it always should. My second column, I have 0. I'm subtracting a negative 2x to the 4th. What do we end up with? Negative 2x to the 4th. Okay. Bring down my next term, which is a 0x cubed. Do our division again. We're taking an x out, so we end up with negative 2x cubed. Take our negative 2x cubed times this whole thing. We get negative 2x to the 4th plus 4x cubed. We're subtracting. Does my first column go away? Okay. My second column, I have 0x cubes. I'm subtracting 4x cubes. We get negative 4x cubed. Okay. Bring down our next term. I'm going to pause the recording. You guys go ahead and try this. All right. We noticed a mistake. I think I said it right and I wrote it wrong. All right, so when we subtract, we had 0 minus negative 2. We ended up with a positive 2x to the 4th. All right, dividing by x, we get positive 2x cubed. All right, there we go. Bring down our 0x cubed. Take an x out. We got 2x cubed. Multiply those back. 2x to the 4th minus 4x cubed. So we should have a positive 4x cubed here. Okay, there we go. Bring down our next one. 4x cubed, dividing out an x, leaves us 4x squared. 4x squared times the x minus 2 gives me 4x cubed minus 8x squared. When I subtract, what do I get? I end up with 8x squared. Bring down our 0x. And we continue. Take out an x. We have 8x multiplying, you should have 8x squared minus 16x, and when we subtract, we end up with 16x. And then we bring down our last one, the negative 32. Divide out an x, we have 16. Multiplying and subtracting. So the question is, x minus 2 a factor of x to the 5th minus 32? You would say yes. It is a factor. We got a remainder of 0. And if I had to write it out, x to the 5th minus 32 divided by x minus 2 gave us this whole big polynomial. X to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. Okay, no remainder. Questions on that? Okay, so again, our goal today was to learn how to do polynomial long division. Tomorrow we will move on to the synthetic part. I have not given you a whole lot of questions in homework because I know they take a little longer. I do want you to take your time, make sure you're subtracting correctly. If you're getting some really weird answers, you probably want to go back and double check your work.